What is palindrome? It is a word, number, or phrase that reads the same backward and forward, like the classic race car, or our example here, step on no pads. Now you might have heard that checking for a palindrome is a common coding interview question. Let's be real, by 2025, asking this exact question might be a bit dated, but the core concept behind it is timeless. This isn't really about palindromes. It is a perfect showcase of a fundamental programming truth that every single problem can be solved in multiple ways, each with its own trade-offs. It is a reminder that there is rarely one best solution. The optimal choice always depends on the context. Let's break down the ways we can tackle this. First up is the reverse and compare method. This is probably the most straightforward approach. You'll see, we split the string into an array, reverse that array, join it back together, and see if it matches the original. It is incredibly readable, a great first solution, but it does create a whole new string in memory, which isn't the most efficient thing we can do. Next, we have the for loop. This is a common manual approach, where we iterate through just half of the string, comparing each character to its mirror on the opposite end. It is efficient because it avoids building a new object and stops the moment it finds a mismatch. This method is the two-pointers technique, essentially variation of the same efficient algorithm, using a while loop instead of a for loop to control the two indexes moving towards the center. It is the optimal solution from a pure performance standpoint. Then there is the array every method. This is a more functional programming style. We use the every method to check if every character matches its mirror. It's elegant and expresses the what instead of the how, but under the hood it is still doing a similar comparison to the loop, just with more built-in abstraction. For a completely different paradigm, we have recursion. Here, we break the problem down into smaller pieces. We check the first and last letters. If they match, we call the function again, on a smaller substring, slicing off the ends each time. It is a demonstration of how recursion works, but it is not very practical for this specific problem, as it can be slow and risk crashing on very long strings due to the call stack. And finally, the stack-based method. This is the most academically distinct solution. We push the first half of the characters onto a stack, which naturally reverses their order, and then pop them off to compare against the second half. It is a great way to see how data structure can be applied to solve problems, but it is likely overkill in this case. I intentionally left out string cleaning, like removing spaces or making all characters the same case, upper or lower, to keep all the focus on the logic of the algorithm themselves. I hope this was a useful deep dive into the many ways to approach a single problem. It's this kind of flexible thinking that makes a coder, not just memorizing answers. The link to the file location is in the description. That's all from my side. Be well.